Hi, good morning. And welcome to the ZP webinar on FoodSense Generation 4. So I do have a FoodSense Generation 4 in front of me, and I will be discussing the testing of quite mild samples today. So I will be talking about this chili puree and this Tabasco sauce, though I don't want to give people the impression that we're not dealing with hot samples as well. So I have some De Bomb here, which I did do a video of recently, and I am going to make a video later on about Psycho juice as well, so I don't want to give that let's say wrong impression. With that said, let me go forward with the FoodSense webinar for this week. So we use this to kind of answer questions and supporting clients. So anyone who's a FoodSense Generation 4 user ends up with or receives personal online training. We definitely give that. We do weekly webinars, so this week you'll see us answering technical questions that have come in from users, and I'm obviously supporting them. What really makes that support so easy, and you'll see that today, is that even though the results of the FoodSense Generation 4 are going to people's phones immediately upon testing, there's also a really nice feature that actually all the data also goes to the cloud as well. So we're not expecting people to interpret raw signals, but there's this kind of backup of ZP. If people choose to share their raw signals with us, ZP is able to look at the raw data and make some sort of deeper insights as to the true hotness of their products. So let me go forward a little bit with that. Also, just say there is a webinar next week, a live streaming webinar. We will do live demonstrations on the FoodSense Generation 4. So just FYI. If you see a link pop up, I'll put the link underneath this webinar as well. And the questions this week are testing samples in methanol. So for whatever reason, if you've got a standard sample and it's in methanol or ethanol, you can have your sample dissolved in that. And I'll explain that, because what the way the FoodSense Generation 4 works is we either do a 1 in 10 dilution, or 1 in 100 dilution, or 1 in 1000 dilution, or 1 in 10,000 dilution. 1 in 10,000 dilution, by the way, is dealing with chili powders like Carolina Reaper and Pepper X. A 1 in 10 dilution, for example, is dealing with things that are fairly mild, like this Tabasco sauce from the McKinney Company, or this chopped chili. I think when we were doing De Bomb the other day, I think we were doing 1 in 100. No, in fact, we were doing 1 in 1000 dilution. So we changed the dilution because we do understand capsaicin has limited solubility in various buffers, but that is part of the training, and we also do have videos about that as well. This week I am dealing with a client who has a kind of 10x expectation on the hotness of their product, but because I'm able to, this client is definitely remote from me, but because I'm able to, or they're sharing their raw data with me, I can look at their raw data, and then I can also compare it against raw data we already have. And then I also want to talk about chili powders being tested. In this case, they're being tested in India, and again, even though they're remote from me, because we have this cloud-enabled technology, I am able to really support them. So question number one is, somebody may have some samples in methanol or ethanol. They may be wanting to then sort of test that. Well, of course, with our chili buffer, because we essentially take one volume and add it to, let's say, 9 volumes to get a 1 in 10 dilution. That dissolves the ethanol and methanol to less than, to 10% or less. And of course, if you've got a very strong sample, you may be doing that as in 1 in 100. So the 10% becomes kind of essentially 1% or 0.1%, or even, let's say, I think it might be 0.00 or 0.01%. So I'm just to say that you can actually have, for whatever reason, if you're making a sort of a chili vodka, etc., you can test those, because in fact it won't damage the sensors. And when I say sensors, I've got some sensors here. It won't damage the sensors, because in fact the dissolution that you do, here's a row of sensors here. The dissolving that you do essentially dissolves that methanol and ethanol into amounts that the sensors can otherwise deal with. The FoodSense Generation 4 is really measuring the total amount of capsinoids in that sample. So I know there's dihydrocapsinoid, there's no hydrocapsinoid, I'm getting that wrong, and then there's capsaicin itself. So these are all different isomers of capsaicin. So we just measure the total amount of all of those molecules rather than individually telling you how much of that and that is. But you find that actually with most products, the bulk of natural products, that is actually capsaicin, with dihydrocapsaicin coming in second, and then the other ones are really a sort of, you know, a very 1%, 2% kind of concentration. So for a fast and accurate result, the FoodSense Generation 4 is a really good instrument. Number two is this will evolve a lot more raw data and a little bit more discussion on science as well. So the title of this question is testing mild hot samples. Now, first of all, I am going to take mild hot. That's a bit of a misnomer. I should just say mild. So I did do some work just last night actually on Tabasco. I know that Tabasco, people always, not always, but people do complain that Tabasco is not very representative, you know, especially in the hot sauce community. So we do have videos as well testing De Bomb. Even though De Bomb advertises itself as 135,000 Scoville heat units, it can actually be quite variable, and this I think came out about 176,000 Scoville heat units. But last night anyway, I was testing Tabasco because I wanted to get a representative sample of something that was quite mild. I know that might seem quite hot in the sort of to the vast generation of consumers, oh, not vast generation, a vast population of consumers, but honestly, with the kind of people who really like the heat, this is a pretty mild sauce. So I took 0.1 milliliters of it and diluted it in 0.9 milliliters of buffer. This is what I was talking about earlier on, that I don't mind if people have a methanol or ethanol sample, because in fact they do an immediately. They take, you know, one volume and add it to 9 volumes of this buffer. It'll immediately dilute the ethanol methanol down to 10%, and if that dilution goes up, then that becomes, you know, 1% and lower. So I'm not that concerned about that. Now that was in question one. This is the video that is on the website. The reason I bring it up is because even though you get a result on your phone, so in this case, if you ever want to look up online, you'll find lots of references that Tabasco sort of ships. I think it ships in a range 2,000 to 5,000 Scoville heat units. I measured this last night at 2,784 Scoville heat units. Every time you do a test, the data actually uploads to the cloud as well. So you do get a nice result on your phone, very clean, you know, Scoville heat unit. It says upload complete, and that upload complete means that actually the data, the raw signal has gone to the cloud. So then you can look at it. You can use your credentials, your username and password to log in and see this. But it also means that if you want support from ZP, you can share it with ZP. So I can look at this sample that I did last night, and I can look at its raw signal, and I do have videos about where this raw signal is and where's it come from, or what it is and where is it coming from. This is not that webinar today, but you know, there's some very obvious peaks, obvious to us, you know, that this is capsaicin, and I can see, you know, our sort of signal. So you know, that's Tabasco. It's fairly mild. It's about in this case it was about 2,500 Scoville heat units, and I can see the raw signal. Now I also wanted to do a chili puree for these people as well, because actually their sample was actually a chili puree. So I've just got something from the local supermarket here. I'll just kind of squirt it out a little bit, just to kind of say that in order to get a good extraction on either fresh chilies, you really have to bring it down to quite a paste. This is just super blended, let's say, but when you make it that kind of paste, that makes it much easier to extract, because the capsaicin is really in the solid material and you need to get it into the liquid state. Now, this was quite a mild let's say chili paste or chili puree. So I actually I got a score on this of about 3,000 Scoville heat units, and that will become clear in a minute. But what I wanted to say was, Slightly unusually, I actually made a dilution of this of, I think this is 1 in 100, I hope, yeah, 1 in 100 dilution here. And then I vortexed it, and then I actually tested it. The reason I bring that up is because this came back at about 3,000 Scoville heat units. In fact, I will just share my second screen here. This came back at about 3,000 Scoville heat units when we measured it, and it's quite mild. But I also did a 1 in 1,000 dilution as well. But the reason I bring it up is because we did get a result on the phone, and then immediately the data goes to the cloud. So I can kind of see the peak I'm looking for. The fact I did 1 in 1,000 means that this is not as prominent a peak as with the, it's actually 1 in 100, I should be saying. It's not as prominent as with the Tabasco. But the reason I'm doing this is because I'm looking at somebody else's sample, and somebody else's sample has an expectation of how hot there is. But I'm able to then look at their signal and compare it against other materials and actually say, you know, you may have an expectation that your Scoville heat unit is this because historically you've thought it was, but we can actually look at the raw signals here and actually say, you know, it's not. So this is the customer sample. They did a 1 in 10 dilution, and immediately it's coming back very mild, but it's simply the signal is very small. It's almost flat. Now the person running this is a food scientist, a food technologist. So, you know, they do have an understanding on, you know, dilution, and, you know, they're very experienced. So they actually did something a little unusual, that they did a 1 in 5 dilution. So they also did a 1 in 5 dilution. This was happening other side of the world, but again, the cloud connectivity meant that I was able to look at their data. And though they did a 1 in 5 dilution, the signal has increased in magnitude to the 1 in 10. So it makes, you know, scientific sense that they were only doing essentially half the dilution. But again, they really got very, you know, we can see peaks in here. So we know it's capsaicin, but it's very mild. And then what I'm able to do then is actually compare it against what they think the Scoville heat unit is, which is about, I think they're thinking their SHU is in the range 2.5 to 10,000 Scoville heat units. I'm able to then, you know, compare it against a classic kind of sample and say, look, you know, that's what the capsaicin peak should look like, and this is what yours looks like, and it really isn't in the hotness that you're expecting. So it's no criticism of course, you know, these senior scientists, senior food scientists and technologists, but it does say that sometimes expectation and these certificates of analysis that people do have from the vendor or from a third-party analytical house, you do have, you know, often with those situations, you don't really see the raw signal, and ZP FoodSense Generation 4 is actually one of those technologies where you actually can see the raw signal. The last one here is, this is work again happening here in India, where they've got 3 chilies, the Guntur chili powder, a green chili powder, and a Tihar chili powder. The powders have actually come to ZP because these people, you know, in the end, we needed to sort of get to the root cause of what was happening here. So they have an expectation of that their chili powder is 30,000 to 40,000 Scoville heat units. We did a series of measurements. Chili powders, by the way, are very heterogeneous. If you take a sample from one part of the chili powder and take a sample from another part of the chili powder, you will not get the same result. You get similar, but you cannot get the same result. Chili powder is not homogeneous throughout. It's not one chemical. It's lots of samples from lots of natural products, so it does have a natural distribution of capsaicin. But we analysed it. We did 4 tests on it, and we got an average of 41,000 Scoville heat units. So they have an expectation of 30 to 40,000. We actually brought it in at 41,000, but 41,000, if you divide 40,000 by 41,000, that's going to be about sort of 2.5% difference. It's well within, you know, experiment. I wouldn't call it error, but well within experimental, let's say, acceptance. The standard deviation and more importantly, the relative standard deviation was 9%. So we've also got a good handle on repeatability of tests. So they have an expectation, we're very close to the expectation, and our repeatability of test is acceptable. The green chili powder, they have an expectation that it's 60,000. We did multiple tests. We got 61,794,000. So it's a very, if anything, we're actually closer to their expectation on this one, because 60,000 divided by 61,000 is approximately, I want to say, about 2% difference, but I'm just approximating there. The repeatability wasn't as good with this one. This is much more like heterogeneous, but still, if you can get a relative standard deviation of 20% or better, that is an acceptable range when looking at these natural products. So we're happy with that. Now this is the controversial one. They've got some Tihar pepper. They have an expectation that it's actually 95,000 to 100,000. I have found references online that say it's actually potentially this powder is in the range of 50 to 60,000 to 170,000. When I test it, or when we test it, we get an average of 39,991 Scoville heat units. But our standard deviation is, again, good. It's like 9%. Now, at this point, you could say, oh, well, the FoodSense Generation 4, must be at fault. But again, see, we get the raw signal. We're not just getting numbers. We can actually see. So the Gunter chili powder, which we meet their expectations, slap on, we're really, really close. So we know what the raw signal looks like there. We can see the peaks, And then this is the Tihar chili powder, which we're not meeting their expectations, but we can see there, and that we can see the raw signal. Again, we've got the peaks, we've even got the same intensity. So, the conclusion actually is that Tihar pepper that you think may be 95,000 or 90,000 to 100,000 Scoville heat units, when we report that it's more like 40,000, actually we're then able to sort of back it up, not just because it's a number. We have the raw signal, and we have other raw signals from other powders that you have, and you can just see, it's kind of it's strikingly similar. So be careful, because I think in this case they may be getting the certificate of analysis from the vendor, and when you find out that the vendor may be getting the certificate of analysis from somebody else, so in fact, there really isn't a otherwise analytical method being used on these products. So question number 1, can you test samples in methanol? Yes, you can, because of that 1 in 10 dilution, or that 1 in 100 dilution, or 1 in 1000 dilution. At ZP, we're actually measuring the total capsaicinoids. But when you actually look at the natural distribution of capsaicins in products, you do find that 80 to 90% of it is actually capsaicin. Then dihydrocapsaicin is making up the bulk of it, and then you've got the other isomers of capsaicin are actually quite low. So that means that we do get a good accuracy versus other analytical techniques. With the low SHU sample, so we got these people who are testing a chili, let's say they're testing a chili paste or chili puree. They think it's 2.5 to 10,000 Scoville heat units, but at least the sample that's going on the sensor is definitely not in that range. And then testing chili powders. So there were 3 chili powders there. We hit 2 of them head on, and then there's this last Tihar chili powder where actually we measure it much milder, but we're then defending it because actually we can see the raw signal. And with this one, we're actually saying, okay, well, show us a certificate of analysis from the third-party labs. And so far, it's not coming. So I've got, just to say, at ZP, we give rapid tests and actually are able to back it up with a raw signal, and then able to kind of manage expectations, because there are lots of different products on the market, and you can then compare them against those signals against those products, and actually say, show let's say a scientific rationale as to why we say, what we're saying is actually true, and sometimes people's expectations are not as accurate. So if you have any questions of ZP, I would say don't hesitate to reach out to us. As I say, there's a webinar next week. I'll put a link underneath the video, and I hope you will attend that. Okay, thanks very much.